Now, one of the things that you may have noticed is that we often have several ways of labeling the same point on the number line. For example, let's say I divide each unit into 4 equal parts. And let's say I count out 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. And I mark this point on the number line. Right? This is the point named 6/4. If I get rid of the marks that I used to divide up the number line, well, that point is still there, right? But now let's say I go through and instead of 4 equal parts, I split each unit into 2 equal parts. Well, now I have another way of describing this point, right? I go out 1/2, 2/2, 3/2. And I get this same point, right? This same point on the number line is identified with the label 6/4 and also with the label 3/2. When we have two labels that mark the same point, we write an equals sign between them. When we have two symbols that describe the same point on the number line, we write an equals sign between them, and we say that they are numbers that are equal. So 6/4 equals 3/2 in exactly the same sense that 2 plus 3 equals 5. They're different ways of describing the same point. Or if you're thinking in terms of counting things, they're different ways of describing the same count of things. When two fractions are equal, we also call them equivalent. That word equivalent for our purposes means that they mean the same thing. 6/4 and 3/2 are different ways of describing the same thing, just as 2 plus 3 and 5 are different ways of describing the same thing. All right, so drawing a picture like this is one way of coming up with different labels for the same fraction. As usual, drawing a picture is not going to be our most efficient plan. But let's look at another picture and think about how we could get some equivalents. Okay, our goal here is to come up with some equivalents of 2/3. And to do that, I'm going to draw a number line with a great big unit. Okay, so here's my unit. Right, this unit is much bigger than what we've seen on our previous number lines. But we can still split it into 3 equal parts. All right, notice these are all the same size. And we can find 2/3. Okay. And now I want to think about how else could I label that point. Let's see what happens if we divide our unit into 4 equal parts. Okay. That doesn't give us any label for this point, 2/3. That's not going to help. Let's see what happens if we divide it into 5 equal parts. No joy there either. How about 6? Ah, there we go. Right? 1, 2, 3, 4. 4/6 is another name for 2/3. Okay. Let's try some more things, right? We're not done. Those can't be the only 2 ways to label that point. I'm not going to draw 7 because that's too hard. Take my word for it that it wouldn't work. Dividing my unit into 8 equal parts doesn't seem to work out. Let's try 9. Oh, 9 worked. But I've got 1, 2, 3, 4, 5, 6 ninths. What pattern do we see? Here's the thing that I notice. I notice that each of these denominators is something times 3. 4/6, well, 6 is 2 times 3. Hey, check this out. Well, 4 is 2 times 2. 9 is 3 times 3. Oh, yeah, and 6 is 3 times 2. Well, if this pattern continues, we'd expect that the next one that works is the one where we multiply the numerator and denominator each by 4. So we expect that the next equivalent we get is going to be 8/12. Let's see. I'm going to divide my unit into 12 equal parts. Well, I have a mark here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 8/12. Hey, cool. Let's do one more. I'd have to multiply my numerator and denominator each by 5. I should get 10/15. Okay, I'm going to have to divide each unit into 15 equal parts. I kind of drew this picture so that would work. This time when I do this, I'm going to start out with my thirds marked in. Look what I'm doing. I'm taking each third and I'm splitting each third into 5 equal parts. Of course, I get 15 equal parts that way. The first third comprises 5 of them, and the second third comprises 5 of them. So, we see why we should expect this to work, don't we? What's going on? We multiply the numerator and denominator by the same whole number. And when we do that, the effect is of cutting each third into the same number of equal parts. So, we could get all sorts of equivalents to 2/3 this way. We could get some that we don't want to draw. We can pick any whole number we like to multiply the numerator and denominator by. We could pick 7. And get 14/21. Heck, we could pick 90 and get 180, 270ths. Of course, this is a picture I don't want to draw. I'd have to draw very small. But I knew that if I did draw that picture, it would end up looking just like this one. Why? Because I took each third and I cut it into 90 equal parts, including the 2/3 that I'm looking at.